then you wonder how could I quantify this very complex jet with a simple 2D vena contractor. It's very difficult, right? But we didn't have anything else to do. We were trying to come close as much as we could. Even the 2D visa method has its own pitfalls. The 2D visa is assuming the orifice is a circle, right? Which is not true. Look at this. The 2D visa is also valid only in a single jet. If the vision has multiple orifices, you cannot do multiple visas and add them together. It is not validated in that situation. Also, the 2D visa assumes a constant flow, which is not true also. So look at this. Some parts of the coaptation line is leaking at one point of the cardiac cycle, some others not. Even the same leaking point, sometimes they're leaking too much and they're leaking less. So what's the concept of this tool? How could they assess the mitral regurgitation? They followed a new concept called the pinhole theory, pinhole model. What is this? In physics, we know all of our calculations in echo are derived from physics, right? In physics, they can calculate the flow through a circle. But there is no physics equation till now to calculate non-constant flow through a non-circular orifice. That's quite difficult for physics now. So what they did, they said, okay, if we know how to quantify through a circle, even if this orifice is not a circle, I will apply a grid of very small circles on that orifice. So they back the orifice with very small pinholes, and each pinhole is a circle on its own. So hundreds of pinholes are applied over the orifice, and then they quantified each pinhole at a time as a circle on its own in each frame in systole. So every hole was quantified alone in each frame of the systole, and then any flow passed through each pinhole will be quantified, and then at the end all of these holes will be added together to give you whatever passed through the mitral